This lecture is on valid and invalid deductive arguments, in particular discussing the material conditional. We're going to cover some really basic invalid types of arguments, invalid deductive arguments, and then focus on the nature of the material conditional, discussing two valid kinds of arguments, modus ponens and modus tollens, and then two invalid deductive arguments, very common invalid deductive arguments, affirming the consequent and denying the antecedent. Now, remember, when it comes to deductive arguments, the sort of gold standard of a deductive argument is a sound deductive argument, where a sound argument is both valid and has true premises. Being sound kind of depends on, whether or not the premises are true. And to find out whether or not premises are true, you usually have to go out into the world and do a bunch of examining the world to find out if the premises are true. And that involves things like doing science. Well, when we're doing logic, we are sitting at our tables, right? We're not finding out things in the world. So for logic, though, we can determine whether or not arguments are valid or invalid. We can do that sort of on our own while sitting and computing in a way. And that's because validity is a special kind of property of arguments, right? It's a valid argument is an argument where the truth of the premises guarantee the truth of the conclusion. That is, on the assumption that the premises are true, the conclusion must follow. And we can figure that out just by looking at arguments. Some arguments that try to be deductively valid, that is, they're sort of the way that they're like the use that they're used for, right? The purpose of their use, the reason that somebody's trying to march these arguments out is to try and be valid, but oftentimes they just fail miserably because they're really bad arguments. However, there are some invalid arguments that are much trickier to spot, and we're going to cover kind of both here. First, we'll see the sort of really easy ones, right? So there are a bunch of really simple argument forms that we can talk about, given the way that we've been talking about logic and propositional logic up to now. One really simple valid argument form we can call conjunctive detachment. So this has to do with sentences that are conjunctions, so sentences of the form like A and B. And conjunctive detachment is an argument form where you move from one statement to another. And here the idea is that you can move from any conjunction to any of the conjuncts. That is, when you're arguing, you're allowed to conclude the conjunct from a conjunction. So if you have the conjunction, Joey is a dog and Felix is a cat, right? You know that that sentence is true, then you can conclude that Joey is a dog, right? It just follows because the conjunction, the way that conjunctions work, both sides have to be true in order for the whole conjunction to be true. So it follows that each of the sides is true on its own. There's a similar but sort of reverse kind of argumentative, like valid argument, that comes with disjunction, and this one we can call disjunctive attachment. And the idea here is that if you know a sentence is true, like A, well, then you can move from that sentence to another sentence, A or B. And this is sort of obvious as well, right? If you have some sentence that you know is true, like Joey is a dog, then you can conclude from that either Joey is a dog or Felix is a cat, right? You can just move from any true sentence that you have to a sentence that has a disjunction in it, where the original true sentence is part of it, right? And the reason that you know that the second sentence, Joey is a dog or Felix is a cat, is true is because you know one of the sides is true, right? Now, so remember, conjunctions you can detach, right? You can pull apart the two, whereas disjunctions you can attach. And that's because of the way that the truth works for both of these cases, right? In both of these cases, truth and validity are preserved from moving from one sentence or statement to the other, right? You preserve truth in going from A and B to A, and you preserve truth in going from A to A or B. Sometimes people, when kind of using these arguments, and these are the simple invalid cases, will just get confused. And they'll confuse one of these things with the others. They'll confuse basically conjunction with disjunction or something like, vice versa. And this ultimately leads to invalid argument forms, right? So here's a really simple invalid argument form. You're not allowed to move from a sentence, like a true sentence, even if it's true, to a conjunction of two sentences where you don't know anything about the second sentence, right? So you're not allowed to move from just the sentence A to the sentence A and B. That's not a licit, an allowed form of deductive reasoning, right? So you can't move from the sentence Joey is a dog to the sentence Joey is a dog and Felix is a cat. Well, why not? Well, because suppose you know that Joey is a dog is true. Does that tell you that it's true that Joey is a dog and Felix is a cat? No, right? Because you don't know anything about whether or not Felix is a cat. So in this case, if you're making that move, you're not necessarily preserving truth. And if you're not preserving truth, then you don't necessarily have a valid argument, because it's possible that the premise was true. Like if Joey was a dog is the premise, and the conclusion is Joey is a dog and Felix is a cat, and it's the conclusion. Well, then you might move from one to the other, and the premise might be true and the conclusion could be false. That's a problem. The same is going to go in the reverse with respect to disjunction, right? So you're not allowed to do disjunctive detachment, right? And that basically works like this, right? So if you have a disjunction, that is a sentence with the word or in it, you can't just pull one of the sides off, right? So if you know, say, A or B, you know that A or B is true, you can't just make the inference from A or B to A, right? So suppose you know that it's true that either Joey is a dog or Felix is a cat. Can you then just conclude that Joey is a dog? No, of course not, right? Because it's possible, like in this statement, that it's one or the other, and you're not sure, right? If you only know that the disjunction is true, you don't know which side of the disjunction is true, right? So like, if you wake up in the morning and you're like, well, either today is Tuesday or it's not Tuesday. Well, yeah, right. Can you conclude from that it is Tuesday? Well, no, of course not, right? Because it's a disjunction. If you know that it is or it isn't, and that's all that you know, right? Without like looking at the calendar, you're not going to be able to figure out, right? You're not going to be able to. So you can't go from a disjunction and detach one of the sides and then make that inferential leap. In this case, right, the truth isn't preserved, and so the argument isn't valid. Now, moving on from the really easy cases to something that's a little bit more difficult, we need to give some background on the nature of conditional statements. So conditional statements, as we've talked about, are statements of the form if-then and statements of the form only if, right, where there's an only if in the middle of the statement. And these statements are really special. They're very important in logic and philosophy and argumentation in general, because they involve what we will call necessary and sufficient conditions. Now, a necessary condition is a condition on something, right? It's any condition on something that must hold for that something to be true. So a necessary condition is something like, well, okay, suppose, I don't know, I want to drive to the store. Well, in order to do that, I must turn on my car, right? It's necessary for me to turn on my car in order for me to drive to the store. On the other hand, we have sufficient conditions, and a sufficient condition is basically any condition for something that, if it's true, it guarantees the other thing to be true, right? So a sufficient condition maybe would be like, suppose I want to buy milk from the store. Well, being at the store is sufficient for me being able to buy milk at the store. And let me go into some more examples here. So here's a necessary condition. Right, so remember, necessary conditions are any condition that must hold for something else to be true. So being a mammal is a necessary condition on being a cat. The idea here is like, in order to be a cat, if something is going to be a cat, it has to be a mammal. It's necessary for it to be a mammal. Being made up of 2 parts hydrogen, 1 part oxygen is a necessary condition for being water, right? If something's going to be water, going to count as water, it has to be made up of H2O. Being a human is a necessary condition for being president of the United States, right? Now, of course, this is something that we could change if we wanted to, if there were aliens or like other intelligent creatures. But at the moment, as it stands, in order to be president of the United States, one must be a human person, right? You have to be. It's a necessary condition on being president that you are a human. Sufficient conditions, on the other hand, again, if the condition is true, then it guarantees something else to be true. So take this case again, but sort of reverse it, right? Being a cat is sufficient for being a mammal. That is, if something is a cat, then it's guaranteed that that thing is a mammal, right? Being a mammal is necessary for being a cat, and being a cat is sufficient for being a mammal. Similarly, being a table is sufficient for being a piece of furniture, right? Anything that's a table just automatically is guaranteed to be a piece of furniture. Being a vegetarian is a sufficient reason for not eating at a steakhouse, right? Just because being a vegetarian just sort of guarantees a good enough reason for not wanting to eat where the main thing that they serve is steak. Now, there's a difference between necessary and sufficient conditions. And ultimately, like, one of the major differences is that often necessary conditions just aren't sufficient conditions, and sufficient conditions aren't necessary. So here are some examples, and just using the example that I showed a second ago, right? Here's something that's necessary but not sufficient. So being a mammal in order to be a cat, right? You have to be a mammal in order for you to be a cat, right? It's necessary that something is a mammal if it's going to be a cat. But being a mammal doesn't guarantee that anything is a cat, right? Like, you have to be a mammal in order to be a cat, but you could also be a dog if you're a mammal, right? You could also be a mouse if you're a mammal. You could be a whale if you're a mammal. So being a mammal doesn't guarantee being a cat. So being a mammal is necessary for being a cat, but not sufficient. Well, the reverse basically works as well, right? It's a sufficient condition, but not a necessary condition. To being a cat is sufficient to being a mammal, but it's not necessary to being a mammal, right? A creature doesn't have to be a cat in order to be a mammal. So if you're a cat, that's enough to count as being a mammal. But other things can be mammals as well, right? It's not necessary. You could be a dog, and that would be enough for being a mammal, but that's not, it's not necessary that you're a dog if you're a mammal, right? Because there's all different kinds of mammals. Sometimes it's easier to think about these things in terms of Venn diagrams, where here, like, you've got these 2 circles, right? The larger circle being the grouping of mammals, and the smaller circle being the grouping of cats, where the grouping of cats, all of them are mammals, so they're within the group of mammals. Now, of course, so being a cat is sufficient or enough to be a mammal. And so there's this special relationship between being a cat and being a mammal, right? If you are in the circle of cats, then that's sufficient, that's enough of a reason to count you as within the circle of mammals. And on the reverse, right, being a mammal is necessary for being a cat. That means that if you are within, in order to be within the circle of cats, one must also be within the circle of mammals, right? So this idea here is this sort of mutual relationship between these 2 things. Being a cat is sufficient for being a mammal. Being a mammal is necessary for being a cat. But depending on how you sort of state it, right, being a cat is not necessary for being a mammal, and being a mammal is not sufficient for being a cat. That's because, if you're a cat, like, all kinds of things other than cats could be mammals, right? There's lots of room still in the mammal sphere. And then on the other hand, right, it's not sufficient to be a cat that you're a mammal in this for the same reason, right? If you're in the mammal sphere, that doesn't mean that you also fall into the circle of cats. This now leads us to the conditional statement and the different valid forms of argument that there are using conditional statements. So here we've got modus ponens, or what's also, in Latin it's called the method of pudding. And modus ponens works really simply. It's a very simple form of argument that goes like this. If C, or ultimately, yeah, if Felix is a cat, then Felix is a mammal, right? Felix is a cat, so Felix is a mammal, right? So we've got if C, then M. C, therefore M. Here are some more examples of modus ponens, right? So it always starts with a conditional statement, and then the antecedent of the conditional, the first part of the conditional, is also stated as a premise. And what follows is the consequent, the second part of the conditional statement. So, for example, if you're a student in this class, then you are a student at Cal Poly. Premise 2, you are a student in this class. Great. Conclusion, so you are a student at Cal Poly. Another one, if the moon is made of green cheese, then the stars must be diamonds, right? The moon must be made of green cheese, right? Or no, the moon is just made of green cheese. So the stars must be diamonds. Super straightforward, right? Even though that argument, of course, is not sound, but it is valid. Why is it valid? Well, there's a sort of guarantee here. If the premises were true, then the conclusion would also be true. Luckily, the premises aren't true because they're absurd. Third argument here, Kamala is vice president only if Joe Biden is president. Kamala is vice president, so Joe Biden is president. This leads us to a common fallacy that occurs right in the vicinity of modus ponens. And this is a formal fallacy called affirming the consequent. Now, okay, so just take this really simple and almost seemingly straightforward plausible argument. Kamala is vice president only if Joe Biden is president. Joe Biden is president, so Kamala is vice president. That sounds okay, doesn't it? But what's wrong with this? Now let's take a different argument, but one that works the same way, in order to sort of show why it is that this original argument doesn't work and why affirming the consequent is so problematic. As the argument goes, if Joey is a cat, then Joey is a mammal. Joey is a mammal, therefore Joey is a cat. This argument doesn't work, right? Why not? Well, Joey, as it turns out, is my dog, and it turns out that Joey is a mammal, but not a cat. And what's wrong with this? Well, the issue is it's affirming the consequent of the conditional statement. Just claiming that the consequent of the conditional statement is true isn't enough to guarantee that the antecedent of the statement is true. And so ultimately here we have a breakdown of the necessary and sufficient conditions between the two statements. And so affirming the consequent ends up being an invalid form of argument, because even though the premises, or when you do affirming the consequent, you could assume that the premises were true, but it might turn out that the conclusion is false. Therefore, the truth is not preserved from the premises to the conclusion, right? You can see that you could assume, right? You can assume that it's true that if Joey is a cat, then Joey is a mammal, and you can assume that it's true that Joey is a mammal, right? On both of those conditions could be true, but it could still turn out that Joey's not a cat because Joey's a dog. Here's another set of examples of affirming the consequent that help show what's wrong with this argument form and why it's invalid. So if there's no gas, the car won't run. The car won't run, so there's no gas. Now that can't be, it seems like acceptable, like it's like a form of reasoning that people go through all the time, right? But it's problematic. Why? Because it's possible for the two premises to be true and the conclusion to be false, right? It is true that if there's no gas, then the car won't run. But supposing that it's true that the car isn't running, that doesn't mean that there's no gas, right? It could be that, the battery's dead, the starter won't go, right? All sorts of reasons. So it could be that there is still gas. Similarly, if I have COVID, then I will lose my sense of smell. I've lost my sense of smell, so I have COVID. Not exactly, right? It could be true that you have COVID, that if you have COVID, you lose your sense of smell. It could also be true that you've lost your sense of smell, but it could be false that you have COVID, right? Because it could be the case that you lost your sense of smell for some other reason. Now, it's in order to avoid affirming the consequent, it's always good to remember how modus ponens works. Remember, so it's if A then B, A therefore B. And you can sort of try to remember this by thinking of it in these terms, right? Affirming the consequent is bad because affirming the consequent goes from right to left, right? If A then B, right, it tries to affirm B and then conclude A. Whereas affirmation in modus ponens always is from left to right. So affirmation is from left to right. Now, conditionals also, kind of like disjunction, have a very special relationship with negation. And what that means is something like this. If negation, if you negate the consequent of a conditional, right, if the negation of the consequent of a conditional is true, then it follows that the negation of the antecedent is also true. And what that means basically is what gives us this other version, this other valid argument form called modus tollens, or the method of taking. And here's sort of how that works, right? If A then B, right, we've got our classic conditional statement. Premise 2, not B, therefore not A, right? So this is the sort of style or classic form of modus tollens. And as you see there, right, we've got our conditional and then we've got the negation of the consequent. The consequent, again, is the second half of the conditional, and then the conclusion, therefore is the negation of the antecedent, not A. Here is a bunch of examples of modus tollens sort of in action, right? So if Joey is a cat, then Joey is a mammal. Joey is not a mammal, therefore Joey is not a cat. Right? If each of those premises were true, then it would be the case that Joey's not a cat, right? It can't be. If Joey's not a mammal, then Joey can't be a cat. Now, of course, the premises aren't true, so this argument is not sound, but it is a valid argument. If aliens have visited Earth, then there's been a massive government cover-up. Premise 2, there has been no government cover-up. So, conclusion, aliens have not visited Earth. Now, this again is valid. It may not be sound. It could be the case that there was still a government cover-up, even if there were no aliens. All right, so take the third argument. If I have COVID, then I need to quarantine. Premise 2, I don't need to quarantine. Conclusion, so I don't have COVID. Again, this also is a valid argument, even if it isn't exactly sound. And finally, if pigs can fly, cows can jump over the moon. Cows can't jump over the moon, so pigs can't fly. And once again, right, this is what I call a valid argument that isn't sound because it's not necessarily, well, the conditional statement is a little bit absurd. When it comes to modus tollens, there is a corresponding way of confusing what part of the argument you're denying, and you get a different kind of formal fallacy, right? So in modus ponens, right, we have this thing called affirming the consequent, which is where you say, thumbs up, true to the wrong part of the conditional statement. In modus tollens, you've got denying the antecedent, where you're saying, no, it's false to the wrong part of the conditional statement. So here again, right, the conditional statement is A, if A then B, and The first half is the antecedent, the A part, and the second half is the consequent, the B part. And remember, a normal modus tollens says if A then B, not B, denies the consequent, and then the denial of the antecedent follows. Whereas in this form, in this invalid argument, we've got the denial of the antecedent and claim that the conclusion is the denial of the consequent, and that's just wrong. So here is an example. If I have COVID, then I will lose my sense of taste. Okay, that's a conditional statement that seems like it's probably true, right? Usually people with COVID lose their sense of taste. Premise 2, I don't have COVID, so I'm denying the antecedent. Conclusion, so I won't lose my sense of taste. Well, that's problematic because there's lots of other things that you could do to cause yourself to lose your sense of taste than just have COVID, right? You could just burn your mouth. So the idea here, the issue, is that the premises can be true and the conclusion could be false. And so we have an invalid argument that does not preserve truth. Here are some more examples of denying the antecedent, the problematic form, invalid form of the argument. If Joey is a cat, then Joey is a mammal. Joey is not a cat, so Joey is not a mammal. Well, wait a minute, that's a problem, right? Because Joey could be a mammal and is a mammal because he's a dog, right? And so the issue here is just because you deny the antecedent, the first part of the conditional, doesn't mean that the consequent, the second part of the conditional, is false. Argument 2, if you behead the king, then he dies. Premise 2, you don't behead the king. Conclusion, so he doesn't die. Well, not exactly, right? Why not? Well, just because you didn't behead him doesn't mean that you didn't stab him or something like that, right? Third one, if you're an atheist, you believe in evolution. You're not an atheist, so you don't believe in evolution. No, like, okay, like that argument sounds like something somebody would actually say, but it's not correct. It's a bad argument. Well, why is it bad? Because it's possible to not be an atheist and still believe in evolution. You can think of each of the premises as being true, right? While the conclusion is false. Remember, denial always goes right to left. So that is when it comes to denying something, that is when it comes to the negation, using the negation in these statements, you go from the right side to the left side. You deny the consequent, and then that leads to the denial of the antecedent. Whereas on the other hand, right, with modus tollens, you always affirmation always goes left to right, denial always goes right to left. And anything other than that is going to be an invalid argument. All right, now beginning to wrap this lecture up, conditional statements, like all sentences that are conditional, they can be either true or false. But it's often harder to spot and explain why a conditional is false, because it's just confusing to say that some statement of the form if then is false. But here's a little test you can run in order to see if a conditional statement is false. You take the conditional and you assume that the antecedent, the left-hand side, the if part, is true. And then at the same time, try and come up with an example where the consequent, the right-hand side, is false. Remember back to our discussion of the nature of the truth function for conditional statements. The truth table for a conditional statement, the only time a conditional statement is false is when the antecedent, the if part, is true, while the consequent, the then part, is false. Now, the basic idea then is just to imagine a scenario where the if part is true, but the then part is false. And if you can do that, then you have a counterexample to the conditional statement at hand. There are lots of cases that you can sort of do this with. Just take any common conditional statement that you hear people say. Oftentimes, like listen to Fox News and find the right-wing media saying some really weird kinds of conditionals, right? So here's one. If Trump didn't get elected, there must have been voter fraud. Well, wait a minute. Why think that? Is it not possible that Trump didn't get elected and there was no fraud? Right? Suppose he lost fair and square by the vote count. it seems like that's totally a possibility, right? It's possible that it's true that Trump didn't get elected. The first part is true. The antecedent is true. And the second part is false. There must have been voter fraud. No, why must there have been, right? Maybe there was some, but who like, it doesn't matter that it's not that there must have been, because it's totally possible that he lost fair and square. Here we assume that the antecedent is true and imagine situations in which the consequent is false under that assumption. Here again is a sort of simple one. If the pyramids seem too technologically advanced for ancient cultures to have constructed, then it must have been ancient aliens that have visited Earth, right? But wait, like, why think that? Why think there's a connection between pyramids seeming too technologically advanced and there being ancient aliens? Like, why think that such a connection between those two things has to exist? We can imagine a scenario in which there are pyramids that are very, very big and seem really, really awe-inspiring for the tools that, ancient people had. And yet we can imagine scenarios in which, no aliens came to build those pyramids, right? It just took lots of long and hard work. What's going on here is, when it comes to denying a conditional statement, when it comes to saying that a conditional statement itself is false, what you're doing is you're denying the connection between the antecedent and the consequent. You're sort of rejecting that there's a necessary connection between one and the other. You're denying that, oh, this is necessary for that, or you're denying that the one is sufficient for the other. And that's ultimately what's going on here. When you have a conditional and the conditional seems fishy, then just ask yourself, well, is this really necessary for the other thing, right? Is the antecedent really necessary for the conclusion, or is it really sufficient for the conclusion? And if you can think like, no, I can imagine a scenario in which the first thing happens and the second thing doesn't, well, then it looks like you're going to have a good case, a good counterexample to that conditional.